Hello, testing. Hello, can you hear me? Okay, let's get started. Today we are going to talk about Lab 3. Lab 3 will be much fun than Lab 2. You are required to collect your own data and generate a report, which require a lot of effort, but it's not really hard. So at first I will discuss about the data collection, about how could you collect all the data you need on the report, and then about how to plot the graph on the report, and finally about some general questions. Let's go to the first part about the data collection. So before we go to data collection, maybe we should have a look of the PDF file. Here, just have a quick look. So all we need to do is learn the LOS condition related to the signal strength. It's quite simple, which is just ask us to collect 10 data both for indoor and outdoor, and then plot the graph of them, and then calculate the slope and R-square value for that. And that's all. So at first, what should we have? So we have at least one mobile phone and a laptop. So if you are using a desktop, you may have some trouble on capturing the data outdoor. So you should better have a laptop, but it depends on you. And for Mac and Linux, we are using Wireshark to help us to capture the packets. And for the Windows 10, we are using the network monitor to capture the packets, which is the same as Lab 2. So what should we do in this lab is we go to the outdoor to capture the file, or you can do the indoor at first. It's the same. So it's very similar as Lab 2. What you need to do is just create a hotspot with your ZID and then connect to the hotspot with your laptop, and then open the Wireshark or the network monitor to start capturing. So here. What we need to do here is, instead of last time, we are required to capture the RSS data in 10 different distance. Let me draw a plot here. So for example, let's do the indoor at first. I assume this is your room, and here is your laptop. Let's say laptop here. I put the laptop in the corner of the room, and then I connect my laptop with my hotspot. Yeah, this one should be your mobile phone or something else. So let's put it like here, the longest distance from the laptop in your room. And then we can like measure the distance from the hotspot to your laptop. And then we just put some label around this area, like put some label on the ground, like in the middle at first, or just slice them into 10 pieces, like put in here. Like this. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But I didn't separate them equally. Sorry, I can't move them. But what you need to do is to make sure each distance is equally. So you can start capturing like this. So at first you put your hotspot at the longest distance and start capturing for like, let's say 1 minute. And then you put your hotspot at this place and start capturing for 1 minute. And then you keep moving your hotspot and start capturing, and so on and so forth, as long as you get the 10 capture files. Does that make sense? So I guess it makes sense. Okay, so let's move on. But you need to be careful of, for each distance, we do one capture, which means generate one CSV file. So we start capturing, like, for example, in this scenario here, I put my hotspot at the longest distance right now, and then I can open my Microsoft Network Monitor. And then I can create new capture. And before the capture, I can like run the command line to ping the hotspot and say, or you just can simply like play a video on your laptop. It will be the same. So you just increase the traffic from your laptop to the hotspot and then start to capturing the data. And let's say we wait for here for like 1 minute and we can stop and save it to anywhere you want. And then we can moving our hotspot to next spot, to next location like here, and then start it again to create a new capture and start. Does that make sense? And at last, you will have 10 files for indoor, and you can open it with Wireshark and save it as CSV files, as we done in Lab 2. And show the broadcast packet in your network monitor, like here. Broadcast. What do you want to see my broadcast? Okay, let's move on. And the key thing for this step is just make sure there is nothing between your laptop and your hotspot. For example, there may have a sofa or a chair or anything else between your hotspot and the laptop. You should remove it. So just make sure your hotspots and your laptop should have like, there is nothing between them, because we need to maintain the iOS condition. Any question for this part? So after this step, we will have 20 different CSV files in our laptop. Okay. I am on a Mac, still having problem capturing Wi-Fi signal. So I guess you are using the newest Mac with M1 chips, which have the problem to capturing the stuff. No? So you may fail to open the monitor mode, I guess. So we will talk about the configuration of fail to capturing the Wi-Fi signal at last. Don't worry about that. I couldn't see the AO 2.1 packets in that CSV. Is there some feature that helps you show them? No, monitor mode in Windows. I couldn't see the A2 packet in that. In which CSV? Did we open any CSV file? How to open monitor mode in Windows? My Windows laptop cannot capture. Yes, me too. So you can see here, what I captured, there is no AO 2.11 protocol, which is raw RSS data, but we can still use them. Like after the capturing, my capture will be looks like this. You can see they still have some signal strength in the UDP and TCP packets from outside to my computer. This one should be the, I guess it's the Zoom server. You can still use them as your data. Does that make sense? So don't worry if you cannot capture the AO 2.11 packets. And there's no way to open the monitor mode in Windows, as far as I know. So what we need to do, just use the Microsoft network monitor to help us to capture it. Or you can install like Linux on your machine and you can use the Wireshark. Capturing on that mode, are we not supposed to see the beacon frames? In that sense, how I'm supposed to capture the noise level? As for now, there's no way to capture the noise level in Windows. So we just ignore it, but we will not use the signal noise anyway. We will not use the noise level anyway. So don't worry about that. Yes, USB wireless adapter will help you to capture the packets. So if you fail to capture the file, so at first you need to check about the configuration. Have you opened your monitor mode on your Linux or Mac machine? And have you set the like configuration, for example here, if you are using the network monitor to capture the packets, you should select the correct interface to capture it. Just make sure the configuration is correct. But if you still have nothing here, like you create a new capture and there still nothing here, and you can make sure your configuration is 100% correct, then you should consider to buy a wireless adapter. So we will talk about later. I will give you some example of the USB wireless adapter to you. So you can consider to buy one. We will talk about this kind of question in general questions. Is that okay? So let's move on to the second part about the report. Yeah. After the data collection, your file should be like, you should get 20 files of CSV file. Let me show you. For example, the outdoor here, you should have 10 different CSV file in your folder and ready to submit it. And with this file, we can go to the next step, the report. So what should we do in the report? It's quite similar as the previous lab, just plot something. So we are going to plot the RSS, which is the signal strength, as our y-axis, and the x-axis is the log distance. Log distance. Let's have a look of it. So the 3 steps here is telling us how to capture the data, which is the data collection. And the second step is to plot the graph on here. You can see our x-axis, we are using the log distance. Does that make sense? Just remember, do not use the distance straight away. We should calculate the log value of it. And then we can plot them. So at first, we are required to plot the raw RSS data on the log distance. And then we need to calculate the RSS data, RSS value into the average value, and then plot them. And write down a paragraph of commentary on there. Let me show you here. Here are some example here, but if your plot is different, just do not worry. Here are just some example which lets you know how to do the plot. So this is not the correct answer. So do not copy the graph here. It's just a demonstration here. You can see the x-axis is the distance after the log calculation. And the y-axis is the signal strength. Is that okay? So for here, I plot all the signal strengths on the plot, on the graph. You can see there are lots of points on here. And then in the second graph, I calculate the average value of them. For here, the average value for them is like minus 33, 28, and then just so on so on. And then you can use the linear regression to calculate what is the slope value of this line and plot them. That makes sense. So in the first graph, it's very straight away. Just plot all the scatter on the graph. And the second one, we need to calculate the average and then plot a straight line on it. And you are also required to calculate the, what is that, the R square value of it. And you can see here, there's some kind of average value here, which is not really make sense. Do you know why? Because let's say the distance is 1 to 10 meters. So the log value should from 0 to 1, right? And here is about the 8 meters. And here is about the 9 meters. And you can see the average signal strength in 8 meters is even better than the 7 meters. Here is 7 meters. So we should consider this kind of value is invalid. So which means is outlier. You can see here, the outlier. So for the outlier, we should remove them and help us to fit in the line. Does that make sense? So what should we do is we just remove these 3 value. And then recalculate the slope. Like this one, like this graph. You can see we didn't calculate this 3 because we consider it as an outlier. Is that okay? Why remove the last value? Because we think it's the outlier. So you do not necessary to do this in with your data or in your report. It's just for demonstration here. So because we think the data here is invalid, so we remove it. But your data may be very perfect and do not require to remove any average data, average value from it. Does that make sense? I'm just talking about if we have any like outlier in our data set, we just need to remove it. And then we can calculate the R square value based on that. Okay, so let's move on. So how to plot this kind of graph? It's very simple. Just use the Excel, Python, Java if you want, or any tools you like. And how to calculate the slope? It's just use the very basic linear regression. There are lots of library with these tools which can help you to solve this problem. And before you do the regression, just make sure you drop all the outlier, as I do, like here. And just drop these 3 because we consider it as an outlier. Okay. And the R square, To calculate the R square, so at first we need to know what is R square. We will use the R square to measure the correlation of regression model. So we use it to measure the quality of the regression model. So if you don't know it, just don't worry about it. We can calculate it with the calculator. Here, how can I click it? Yeah. Oh, anyway, I can't click it right now, but you can search online. There are lots of calculator like R square calculator. Yeah, search online calculation. And you can choose the first one. Just for here is for the X, we put the log distance here. Let's say 0 0.1, 0 0.2, 0 0.4, and Y is our average signal strength. And then we can start to calculate. And we can get the R square very easily. Or you can use the other tools to get it. It doesn't really matter. Does that make sense? And let's go to the question here. What if I can't capture any packets, as we mentioned before? So at first you need to make sure you have set the right configuration. It's not your fault. And then we can consider the other way, like borrow a laptop from your friend or use your old laptop or buy a wireless adapter. There are lots of wireless adapter here. Let me open the link. Like this kind of adapter will work. You can just search online about the wireless adapter. Most of them will work. So I'm not making any advertisement here. So you just select by yourself, okay? Okay. Do we calculate can we calculate with the Excel? Yes, why not? We can calculate the R square value with any tools you want. And we calculate the R square value based on the average values instead of the raw data. Does that make sense? So how do you calculate the slope? Then you can use that value to calculate your R square value. When is the report due? It's next Monday. And yeah, and that's all for today, I guess. So if you have any question, just stay here and ask me. I will try my best to answer a question. But if you have nothing to ask, you can feel free to leave. And again, I want to talk about the GitHub I'm using here. So for the recording, I will put all the recording in the link. So if you are like here, you can click the link and hear the recording of the lab. And you can also attend another tutorial if you want. So if you have any question during before the Thursday, you can just join any tutorial available here and ask the tutor your question. And there are some general question I will put on the documentation here. For example, the Lab 2, there are lots of students ask me the same question. So I just put all the answer here. And you can also have a look if you have the same question. But the best way to solve your question is to come to the lab online and you can ask me directly, or you can post them on the forum. So we will answer you in 24 hours. And I will put the link on the chat. Windows. Windows Network Monitor reports the RSS as a positive DBN. What does this mean? I think just wrong display, I guess. It will be always negative. Because NetMoon does not have the option to record noise level and SNR. Will we be needing this in later labs? No, we are not required to need this kind of data. We will not be required to use the noise level and signal to noise ratio anymore. So don't worry about that. So if we do need them in the future, we will consider your situation here. So just don't worry about it. And again here, it's just for demonstration, the graphs. So if your graph is totally different as mine, it will be totally okay. I'm using these graphs to just for demonstration. But the x-axis and y-axis should be very similar. Like the x-axis, I use the log distance, and y-axis use the signal strength. We should keep the same, and maybe the title we can use the same one. Do we need to open monitor mode of network monitor when we use to capture the data? I don't think we can open the monitor mode here. Some computer will be able to do that, but like mine are not able to do this. You can find to open the monitor mode here. If you can, just open it, and you will be able to capture the raw wireless packets, which is in AO 2.11 protocol. That would be excellent. But if you cannot open the monitor mode, just use the TCP or UDP packets, which have the signal strength information here. Does that make sense? So you can start to working on Lab3 now, and you can come back to the lab tomorrow or something, on Thursday. Why do we have to ping and 500 before recording the data? We just want to increase the data, the traffic between my computer to the hotspot. You can, if I didn't put N500 here, it will stop for 4 packets here. So I use the number of 500, which means I will send 500 packets from my computer to the hotspot with 1 second interval to make sure I will always connect with my hotspot and there's have some traffic on it. But instead of using this way, you can like generate, open YouTube and play a video, which will create more traffic than this one. All you need to do is just open the YouTube and play a video before you start capturing. Why did we have to do ping? Yeah, I already answered this question. Yep, and we do this 20 times for the different data. Okay, you may have misunderstood on how we collect the data here. Are you talking about this one? So it is 20 times, and the basic difference is the distance and the environment here. You can see here, we need to do both indoor and outdoor. So at first we can scale 10 different distance indoor, and then we can start collect the data. Yeah, and go to the outdoor, you can scale. If you can scale the same distance, it will be very good. Like, for example, you can scale the indoor for like 1 meters, 2 meters, 3 meters, 4 meters, 5 meters to 10 meters. And then you can go to the outside, go to the outdoor and start to collect the same distance again. And just make sure there is nothing between your hotspot and your computer while you're capturing. And finally, you will get 20 CSV files, which can use them to plot this kind of graphs. You can see in these graphs, I use 10 CSV file. This one is for 1 meters or 0 meters, 0 meters. This one is 1 meters, 2 meters, 3 meters, 4, 5, 6, 7, 8, 9, 10 meters. Okay. I saw your post on YouTube video about how to use the network monitor, but when I try to turn on the monitor, I cannot get any access points. So I guess you have nothing wrong on the configuration here. So that's maybe because your computer is not supporting on your network interface. It's not supporting the monitor mode. So you can consider to buy a wireless adapter here, as we suggest. Open the link to buy this kind of stuff and have a try again. But when I turn off the monitor mode, I can capture the data with RSS normally. Do I still need to buy a unit USB adapter. I don't think so. If you are be able to capture the RSS, like you can find the signal strength and SSID inside your package, then you can use them. Just make sure your source address is your computer. No, it's the receive address, sorry. So here, the destination, you can see here in my package, the destination is always my computer. The IP address of my computer is 192.168.168. This one is my computer. Just apply a filter here. And then you can use them. And if you still worry about that, you can just like write out this thing on your report. You can say, I'm using the like TCP and UCP package here because I cannot capture the AO2.11, the raw wireless data. Just mention it on the report and you will be fine. Yeah. So does anyone have another question? Why the signal strengths you show are all positive TBM. Market trace are all negative. They should be negative. Yeah, show them in positive. Zoom in here. You can see them in my plot. It's negative. Should be negative. And if you're not sure about it, you can just search on the internet and it will tell you the signal strength will be always negative. I think here in Wireshark, they just omit the negative symbol here. Don't worry too much about it. First one, banana. Do you have any question?